Black holes are some of the most fascinating and mysterious objects in the universe. These cosmic giants can have masses ranging from a few times that of our Sun to millions, sometimes even billions, yet they remain virtually invisible to us. Until recently, our understanding of black holes was limited. But thanks to groundbreaking research over the past 2 decades, we've begun to uncover their secrets. In a recent announcement, physicist Michio Kaku revealed something truly monumental: we may finally be learning what lies inside a black hole. This discovery is shedding light on mysteries that have puzzled scientists for decades. Although many of us have heard of black holes, there's still a lot of confusion about what they really are. The concept dates back to 1916, when Albert Einstein published his theory of general relativity. His equations predicted the existence of black holes, but at the time, they were purely theoretical. It wasn't until the 1960s that observational evidence emerged. Astronomers studying the constellation Cygnus noticed a bright blue star emitting X-rays. These X-rays weren't coming from the star itself but appeared to be drawn toward a massive invisible object, something so dense that not even light could escape its pull. That object was later named Cygnus X1, and it became the first widely accepted black hole candidate. This moment marked a turning point in astrophysics. It was the first solid proof that black holes were real and not just a strange prediction of Einstein's equations. Located around 6,000 light-years from Earth, Cygnus X1 showed us just how powerful these entities are. It has such extreme density that its gravitational pull can trap even radiation. Since then, astronomers have been on the hunt for more black holes, and they've found plenty. Today, it's estimated that there could be up to 100 million black holes in the Milky Way alone, although most remain undetected due to their elusive nature. The most terrifying feature of a black hole is its gravity. Once something gets too close, there's no escape. It gets pulled inward and crushed into a point known as a singularity. If a person were to fall into a black hole, they would undergo a process called spaghettification, where their body would be stretched thin like a strand of spaghetti. And long before reaching the center, they would perish from the intense gravitational forces. Fortunately, the nearest known black hole is about 1,500 light-years away, close in cosmic terms, but far enough not to worry us. For now? One of the biggest breakthroughs came in 2019, when scientists released the first ever image of a black hole, the supermassive black hole at the center of galaxy M87. This wasn't a simple snapshot. It took years of data collected from radio telescopes around the globe, stitched together using complex algorithms to create the iconic orange ring image. It was a major leap forward in our understanding. This image showed that black holes are more than just empty holes in space. They have structure. To reach the core of a black hole, 3 distinct layers must be passed. 1. The event horizon. This is the point of no return. 1. Once crossed, nothing, not even light, can escape. 2. The photon sphere, a region where light orbits the black hole. 2. If you were here, you'd see photons trapped in a circular path. 3. The singularity, the heart of the black hole. 3. A single point of infinite density where the known laws of physics break down completely. But here's where it gets even more intriguing. Some physicists believe that instead of being destroyed in a singularity, matter might travel through a kind of tunnel, a shortcut through space and time known as a wormhole. This tunnel, theoretically connecting 2 different points in space or even 2 separate universes, is called an Einstein-Rosen bridge. To understand this, imagine spacetime as a flat sheet of paper. If you draw 2 dots and then fold the paper so the dots touch, you've created a shortcut. That shortcut is the basic idea behind a wormhole. While these concepts sound like science fiction, they actually emerge from Einstein's theory of relativity. The problem: wormholes are believed to be extremely unstable. They'd collapse almost instantly unless held open by a form of exotic matter, something we haven't discovered yet. But if they could exist and be stabilized, black holes might not just be cosmic destroyers. They could be portals to other realms of spacetime. This raises a mind-blowing possibility: could we one day use black holes or wormholes to travel through the universe, or even through time? It's a question that remains unanswered, but it's one that fuels the imagination of scientists and sci-fi lovers alike. So, what do you think? Are wormholes real, or just a beautiful theory? Are black holes gateways to something greater, or dead ends of reality? Thanks for watching. If you're fascinated by the mysteries of space, be sure to like the video and subscribe so you don't miss more content like this. Until next time, stay curious.